Kinematics is motion. Earlier, we discussed about displacement, velocity, and acceleration as kinematic quantities. Now, what is a particle? In engineering, very often we assume that a body is a particle. For an example, we can ignore the shape and size of a car when designing a bridge. It doesn't matter what kind of a car you drive when analyzing this huge structure. What's important is the weight of the car. Similarly, if you are flying from Paris to Los Angeles, the size of the plane is of no consequence when compared to the distance. We can consider the plane as a particle. We will define a particle as a concentrated mass and we will represent it as a point. We can solve a large number of problems in kinematics using the particle assumption. So let us look at a particle in motion. Rectilinear motion is a motion in a straight line. Consider a particle moving in that way. To identify the beginning and how far the particle travels, we need a reference. For this, we will use a coordinate system. In this case, we will simply show a horizontal line with an origin to indicate where the motion begins and an arrow on the right end of the line showing the positive direction. So at a particular time, the particle starts moving from the origin to the right to a new location P in time. It further moves from point P to a new point P prime in time t plus delta t. We can denote the distance traveled by letter x and delta x respectively. Displacement delta x over the time taken delta t is the average velocity of the particle. There are some interesting things about velocity you should know. It may be hard to believe, but we humans can see velocity or speed, but can't really feel it. Imagine yourself in a plane flying at 400 miles per hour at an altitude of 40,000 feet, cruising with no turbulence. Nice, smooth ride. You can read, eat, and take a nap, and your body does not feel the speed at all. However, you can see if a cloud passes by. This is because the cloud is moving in relation to you. Similarly, if you are in a car, you can see everything outside moving fast in the opposite direction that you are traveling. You are able to see it because there is some reference. Anyhow, now you know that the velocity is the time rate of change of the position coordinate x. The velocity is positive or negative depending upon whether the corresponding displacement is positive or negative. The instantaneous velocity instead of average velocity can be obtained by choosing shorter and shorter time intervals and correspondingly smaller displacement increments. Thus, the expression for velocity can be written using calculus as v is equal to dx over dt. Acceleration is when the velocity of a particle changes. As you know, our body does not feel velocity, but it can feel the change in velocity. Imagine again yourself in a plane flying at 400 miles per hour at an altitude of 40,000 feet, cruising, but there is turbulence. You are now unable to eat or read. The captain is asking you to go back to your seat and fasten your seatbelt. You immediately feel this because the speed and perhaps the direction of the plane has changed slightly. You can also experience acceleration if you slam the brake of your car and try to bring it to a stop very quickly. Roller coasters are thrilling because your body senses the change in the speed and the direction. Your body is simply responding to Newton's law. Let us assume that the particle in consideration changes its velocity as it moves from point P to P prime during the time delta t. You can imagine this as slowing your car down or speeding it up. If we denote the change in velocity by delta v, then the average acceleration is delta v over delta t. The instantaneous acceleration instead of average acceleration can be obtained by choosing shorter and shorter time intervals and correspondingly smaller velocity increments. Thus, the expression for acceleration can be written using calculus as a is equal to dv over dt. With a clear understanding of displacement, velocity, and acceleration, We can now develop expressions relating them so we can solve problems.